Isang mapagpalang araw, my dear students. Ngayon, itong video na to ay pag-aaralan natin ang colligative properties. No? Let me share with you my PowerPoint presentation. So, ano ba yung objectives ng video lesson na to? That at the end of the video, you will be able to describe what colligative properties are, explain the different colligative properties, solve problems involving them, and develop appreciation of these properties as you apply them to real-life situations. Okay? Now, colligative properties are physical properties. So, remember yung dalawang uri ng properties. Merong physical properties at saka chemical properties. So, yung colligative properties are just physical properties of solutions. No? So, they involve solutions, which depend on the amount of solute particles present and not on the kind of solute or nature of solute present in the solution. Okay? Colligative properties include vapor pressure lowering, freezing point depression, boiling point elevation, and osmotic pressure. Okay? So, how does vapor pressure lowering happen? No? So, meron tayong figure dito. I'll try to explain to you and help you visualize no paano yung bumababa yung vapor pressure. Okay, so ano ba yung vapor pressure? Let us think of it as the rate of escape. No, so yung mga liquid particles, ang tendency no is from order to disorder. Ang tendency no mga yun ay to escape the liquid state and go into the gaseous state. No, so yun doon natin siya titingnan. So, yung rate of escape ng mga yun ay tinatawag nating vapor pressure. So, suppose meron tayong 2, 4, 6, no? 6 water molecules, no? So, yung vapor pressure ay nire-represent nitong black arrow na to. No? So, meron silang tendency to escape, no? To escape the liquid state and go into the gaseous state. No? So, bawat isa dun sa 6 na water molecules ay may 1/6 rate of escape. No? Kung sa contest yan, yung chances na manalo ng bawat isa ay 1/6 kasi 6 sila. 6 silang naglalaban-laban. Parang ganun. Ngayon, pag dinagdagan natin ng, let us say, 2 molecules of sugar, anong nangyari? No? Hindi na bago yung number of solvent particles, no, yung water molecules. However, these 2 additional sugar molecules resulted to what? No? Nangyari. So, naging 8. Naging 8 ngayon yung particles. So, ang rate of escape na yun ng bawat isa sa mga water molecules ay 1/8. Initially, 1/6. Tapos, naging 1/8. Okay, no? Kahit hindi siya nabago, no, yung number of solvent particles, but because of the additional solute particles, in this case, sugar, we were able to clearly see how the vapor pressure lowering occurred. Okay, so itong blue arrow na to, downward, ay yung atmospheric pressure. No? So alam natin yung rate of escape or vapor pressure ay upward. No? Tumatakas yung mga water molecules at gusto nilang maging mga liquid water molecules at gusto nilang maging gas. Tapos yun namang pressure sa atmosphere, tinutulak sila pababa doon. Stay lang kayo dyan. Hindi kayo pwedeng tumakas. Parang gano'n ang drama nila. No? So itong dalawang pressures na to, yung vapor pressure at atmospheric pressure ay naglalaban yan. And when they are in equilibrium, we say that we have the boiling point, okay? Where the vapor pressure and atmospheric pressure are equal, okay? Now, doon sa second scenario natin, dahil nagdagdag tayo ng sugar molecules at nakita natin na bumaba yung vapor pressure, no? Kailangan nating mag-supply, no? Mag-supply ng additional thermal energy or heat so that the vapor pressure will equalize the atmospheric pressure dahil bumaba nga yung vapor pressure. So yung additional no, amount of heat na yun would cause no, an increase in the boiling point. So yung tinatawag natin boiling point elevation. para ma-compensate, no? Para ma-compensate yung ibinaba sa vapor pressure, kailangan natin mag-supply ng energy, no? So that it will overcome the atmospheric pressure. So yung dinagdag natin na yon will be equal to the boiling point elevation. Along the same line of argument, magkakaroon naman ng freezing point depression kasi mas arranged na sila, no? Yung structure nila mas arranged na kaysa sa pure solvent. So mas mababa yung freezing point. And then the last one is osmotic pressure. We'll discuss osmotic pressure later. Okay. Now, this is what I mentioned earlier and what I explained, that the presence of a non-volatile solute lowers the mole fraction of the solvent. Now, with relatively fewer solvent molecules, the rate of their escape is diminished and thus vapor pressure is also lowered. Now, yung guiding principle nun ay Raoult's law, which says that the partial vapor pressure at a given temperature of a volatile component of an ideal solution is equal to the product of the mole fraction of this component in the solution and the vapor pressure of this component in the pure state. No? So, dito yung component na sinasabi ay yung solvent. Okay? So, now if you let P be the vapor pressure of solution, X sub B be the mole fraction of solvent, and P superscript the vapor pressure of pure solvent. No? Ano yung sinasabi ng Raoult's law? Yung vapor pressure ng solution daw ay equal sa product, no, ng mole fraction ng solvent and the vapor pressure of the pure solvent. Okay? Pero alam naman natin na ang vapor pressure, ang mole fraction rather ng solute at ang mole fraction ng solvent, ang sum niyan ay always equal to 1. Such that we can substitute X sub B all the mole fraction of solvent by 1 minus X sub A. And we can substitute this in our equation I in X sub B such that P now, which is the vapor pressure of solution, is equal to quantity 1 minus X sub A times P superscript. And then distributing, we have P superscript minus X sub A P superscript. And thus, X sub A superscript P is equal to what? The vapor pressure of the pure solvent minus the vapor pressure of the solution. So here we can clearly see, no, the decrease in the vapor pressure of the solution. Kita natin na mas mataas ang vapor pressure ng pure solvent. Now this difference, P superscript minus P is what we call delta P, or the vapor pressure lowering. Conversely, we have delta P, or the vapor pressure lowering, equal to X sub A P superscript. Ano yung X sub A? Mole fraction of the solute. No? Ano yung P superscript? Vapor pressure ng pure solvent. So, mapapansin nyo, meron tayong dalawang formula. No? Yung P is equal to X sub B P superscript. Ano yung P? Vapor pressure ng solution. Yung delta P naman, vapor pressure lowering. No? Lowering is equal to X sub A mole fraction of the solute times the vapor pressure of the pure solvent. So kahit alin yan pwedeng gamitin. Okay? So let's try to use Raoult's law in this particular problem. Calculate the vapor pressure of a solution of 20.0 gram of sucrose with formula C12H22O11 in 80 grams of water at 25 degrees Celsius. The vapor pressure of water at 25 degrees Celsius is 23.8 torr. So merong table talaga, no, na nagpapakita ng mga vapor pressure ng mga solvent. Okay? Hindi siya universal constant na like yung gravity, no? Ito constant per material. So for water, the vapor pressure at 25 degrees Celsius is 23.8 torr. Okay, so very dependent yan natin sa temperature, no? So dapat ina-identify yung temperature. So abstracting the data, mass solute is equal to 20 grams. Mass of solvent is equal to 80 grams, and we are required to solve for the vapor pressure of the solution. We know that the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the solvent. So substituting, ano ba yung X sub B, mole fraction ng solvent. Ang solvent natin 80 grams, which is water. So 80 grams divided by 18. Ganun din sa denominator. Pero idagdag natin yung mole fraction ng solute. Ang solute natin 20 grams, which is sucrose, C12H22O11. Carbon is 12, hydrogen is 1, oxygen is 16. So the molecular weight of sucrose is 342 gram per mole. So solving for X sub B times 23.8 torr. So the vapor pressure of the solution now is equal to 23.48. No? So bumaba. No? Ine-expect naman natin yun. Kasi ang vapor pressure ng pure solvent ay 23.8. Yung solution natin ay 23.48. So, sinunod niya yung roles. No? Number 2, boiling point elevation, which is denoted by delta T sub B. So, ano yung sinasabi? A mole of a non-volatile, non-electrolyte solute elevates or increases the boiling point of a given amount of solvent by a constant amount known as the molar boiling point constant, or K sub B. Again, this constant is a constant per material, no? So iba ang K sub B ng water sa ibang solvent. Okay? So delta T sub B is equal to K sub B times M, where K sub B is the molar boiling point elevation constant in degrees Celsius kilogram per mole. M is the molality of the solution. And delta T sub B, or the boiling point elevation, is the difference between the boiling point of solution and the boiling point of the pure solvent. So this time, the boiling point of the solution is greater than the boiling point of the pure solvent. So we calculate the boiling point of a solution made by dissolving sugar in water. In water, the molality of the solution is 0.2 molar. K sub B of water is 0.52 degrees Celsius kilogram per mole. So we are given the molality of solution, which is 0.2 molar. K sub B is 0.52 degrees Celsius kilogram per mole. We are required to solve for the boiling point of the solution. We know that delta T sub B is equal to boiling point of solution minus boiling point of pure solvent, such that the boiling point of the solution, which is the unknown, is the sum of delta T sub B, which is the boiling point elevation, and the boiling point of the pure solvent. But delta T sub B is equal to K sub B times M. So we just substitute K sub B, which is 0.52, tapos molality, 0.2 mole per kilogram, plus the boiling point of water. No? Hindi na yan sinabi, pero alam naman natin na 100 degrees Celsius. No? So, okay, tingnan natin yung dimensional analysis. Kilogram will divide itself, mole will divide itself. May ano matitira? Degrees Celsius plus degrees Celsius. The unit is degrees Celsius. So we have 100.104 degrees Celsius as the boiling point of the solution. And note that there is an increase, no, from 100 to 100.104. So indeed, there is an increase in the boiling point because of the additional solvent. Number 2, or problem number 3 pala, I should say, when 2.832 grams of a compound is dissolved in 50 cc or cubic centimeter of carbon disulfide with density of 1.263 gram per ml, the solution boils 0.411 degrees Celsius higher than pure carbon disulfide. What is the molecular weight of the compound? Okay. So given K sub B, again, this is taken from the table, no, constant for K sub B, 2.35 degrees Celsius kilogram per mole. Abstracting the data, the mass of solute is 2.832 grams. The volume of the solvent is 50 ml. The density of the solvent is 1.263 gram per ml. So this early, it is safe to surmise that we will be able to solve for the mass of the solvent by multiplying the volume with the density. Delta T sub B, or the boiling point elevation, is 0.411 degrees Celsius. We are required to find the molecular weight of the solute. So delta T sub B is equal to K sub B times M, where M is the mass of solute divided by molecular weight of solute times kilogram solvent. So ito yung unknown natin. And then rearranging, no? So applying a multiplicative inverse. No? So we have molecular weight equal to K sub B times mass of solute divided by delta T sub B and mass of solvent in kilograms. Then substituting, we have K sub B is 2.35 degrees Celsius kilogram per mole. The mass of solute is 2.832 grams. So delta T sub B is 0.441 degrees Celsius. The mass of solvent in kilograms. So ito yung mass, no? At paano natin nakuha? Minultiply natin yung volume sa density. So 50 ml times 1.260 gram per ml. ml divides itself. So the unit is grams. No? Times 1 kilogram per 1,000 grams. So gram will divide itself. Okay? Tapos kilogram will divide itself. No? Degrees Celsius divided by degrees Celsius. So the unit left with will be gram per mole. And the magnitude or the measure is 238.97 gram per mole. So magandang mahasa kayo sa dimensional analysis kasi mache-check nyo kung tama yung solution nyo base dun sa unit na makukuha niyo. Dapat yung unit, yung desired unit ng desired quantity, no? Ang quantity natin ay molecular weight. So gram per mole na unit. Okay? The third colligative property is freezing point depression, denoted by delta T sub F. No? So a mole of a non-volatile, non-electrolyte solute lowers the freezing point of a given amount of solvent by a constant amount known as the molar freezing point constant K sub F. So mathematically, delta T sub F is equal to K sub F times M. And delta T sub F is equal to freezing point of pure solvent minus freezing point of solution. Bakit? Dahil nga bumaba yung freezing point. So mas mataas yung freezing point ng pure solvent. Pareho rin naman K sub F ng unit delta C kilogram per mole. M is molality of solution. F is freezing point of solution. F superscript freezing point of pure solvent. So kung mapapansin nyo, lahat ng may superscript ay referring to pure solvent. So yung F ay freezing point ng pure solvent, yung B superscript ay boiling point ng pure solvent, yung P superscript ay vapor pressure ng pure solvent para madaling matandaan. Okay? Problem number 4. What would be the freezing point of a solution made by dissolving 5 grams of a compound? Molecular weight is 75 gram per mole in 100 grams of water. K sub F of water is 1.86 degrees Celsius kilogram per mole. So abstracting the data, no, mass of solute is equal to 5 grams. Mass of solvent is equal to 100 grams. So we convert this into kilograms. So this will be 0.1. Okay? So we are required to find the freezing point of the solution. So we know that delta T sub F is equal to K sub F times M. And delta F is equal to F superscript minus F, or freezing point of pure solvent minus freezing point of the solution. Okay. So rearranging, the freezing point of the solution is equal to the freezing point of pure solvent minus delta T sub F. But delta T sub F is equal to K sub F times F. Okay. So just substitute the data. The freezing point of the pure solvent, which is water, is 0 degrees Celsius, no, minus K sub F 1.86 degrees Celsius kilogram per mole. Tapos molality 5 grams, no, divided by the molecular weight, which is 75, divided by the mass of water in kilogram, which is 0.1. And therefore, the freezing point of solution is negative 1.24 degrees Celsius, which is indeed lower than the freezing point of water, which is 0. So tama na naman yung ating solution. Problem number 5. The antifreeze commonly used in car radiators is ethylene glycol, C2H4, quantity OH2. Now, how many grams of ethylene glycol should be added to 1 kilogram of water to produce a solution that freezes at negative 15 degrees Celsius Itong mga ganitong sitwasyon, hindi naman nangyayari sa atin sa Pilipinas kasi hindi naman i-snow dito, but in countries where there's winter, there is a marked change, no, a decrease in temperature. So, nagni-negative, kailangan yung antifreeze. Otherwise, yung tubig sa radiator, frozen yan at hindi mo magagamit yung sasakyan mo. So, ganun yung sitwasyon. So, mass of the solvent is 1 kilogram. The freezing point of the solution is negative 15 degrees Celsius. K sub F is constant, 1.86. We are required to find the mass of the solute. So we know that delta T sub F, or the freezing point depression, is equal to K sub F times M. And M is just mass of solute divided by the molecular weight divided by kilogram. Ito yung ating unknown mass of solute. Okay? So applying again additive multiplicative inverse, the mass of solute is equal to T sub F, ayun, magiging sama-sama na siya, T sub F MW times kilogram solvent divided by K sub F. But delta T sub F, or the freezing point depression, is equal to freezing point of pure solvent minus freezing point of the solution. Okay? Times MW times kilogram solvent divided by K sub F. Okay, the freezing point of the pure solvent is 0 minus negative 15. So magiging 0 plus 15 siya, no? Times 62, which is the molecular weight of ethylene glycol. Computin lang mula dito sa formula. Carbon is 12, hydrogen is 1, oxygen is 16. Divided by K sub F, which is 1.86. And therefore, the mass of ethylene glycol, which we need to add to 1 kilogram of water, is 500 grams. Okay? So kung ang temperature ay negative 15 o negative 14, no, hindi na mag-freeze yung radiator. But pag lower than negative 15, mag-freeze pa rin yan. Okay, granting the temperature is negative 15, so safe tayo dyan. The last colligative property is osmotic pressure, which we denote by pi. Okay. So osmosis is the passage of solvent molecules through a semi-permeable membrane from a region of lower concentration, so higher vapor pressure yun, to higher concentration, lower vapor pressure. Okay, so the pressure which prevents that passage is what we call osmotic pressure. Okay, so two solutions having the same osmotic pressure are called isotonic. No? Suppose there is one solution with a higher osmotic pressure than a second solution. The first solution, which has a higher osmotic pressure, is said to be hypertonic to the second. And the second one, which has a lower osmotic pressure, is said to be hypotonic to the first. Okay? So here's the formula. No? May parang PV is equal to nRT. No? PV is equal to nRT. No? Yung pressure natin, dinenote natin by pi instead of P. So pi is equal to nRT over V. No? Ito ay hindi natin, na-meet na natin to before, tong equation na to. Yung PV is equal to nRT. But instead of using P, as I mentioned, I am using pi. Bakit? Wala lang. Yung mga nakikita natin sa libro para hindi tayo, ay, bakit ganun ibang ginagamit namin? Pero pwede rin mang-P yan. Okay? Wala namang batas na nagbabawal. Kaya dinidefine natin dito, yung pi natin, yun yung pressure. No? But note that the number of moles divided by volume in liters, no, is equal to the molarity. And therefore, we can substitute this with M. So yung N over B magiging M. So magiging MRT. So madaling tandaan. Osmotic pressure is equal to MRT, no? Where M is the molarity, R is the molar gas constant with value of 0.0821 liter atmosphere mole Kelvin. Hindi yan minus liter atmosphere mole Kelvin. And then temperature in Kelvin. Okay? So for problem number 6, find the osmotic pressure of blood at normal body temperature, which is 37 degrees Celsius, if the blood behaves as if it were a 0.296 molar solution of a non-ionizing solute. So given molarity is 0.296, temperature is 37 degrees Celsius. Okay, so we are required to find the osmotic pressure pi. Pi is equal to MRT. So M is 0.296, so this is direct substitution. R is 0.0821. So yung temperature degrees Celsius, convert natin sa Kelvin by simply adding 273.15. Okay? Mole divides itself, liter divides itself, Kelvin divides itself, degrees Celsius plus degrees Celsius is equal to degrees Celsius divided by degrees Celsius. That's equal to 1 times atmosphere. So the final unit is atmosphere. So the osmotic pressure is 7.54 atmosphere. Okay, so that's it. Remember to always choose to do good and be happy with the choice. Yun ang ibig sabihin ng happiness is the choice. No? Piliin palagi gumawa ng mabuti at maging masaya sa ginawang pagpili. Thank you for listening, class. You stay safe and you stay healthy. So I'll see you when I see you. Bye for now. Bye-bye.